Hello everyone. Welcome to Collegewali PADHAI. So let's begin with the introduction of chemistry with the concepts of classical mechanics and quantum mechanics. And let's create a differentiation among them. Sorry, let me write in a clear manner. Classical mechanics, quantum mechanics. Classical mechanics is basically for macroscopic particles. Quantum mechanics is for microscopic particles. Then classical mechanics is based upon Newton's law of motion. Newton's law of motion. This is based on Heisenberg's uncertainty principle. Then it is based on Maxwell's electromagnetic wave theory. Electromagnetic magnetic wave theory. This is based on Planck's quantum theory. Theory. Then here the system defines the force on the particles, position as well as velocity. In classical mechanics, whereas in quantum mechanics, it gives the probability of what? Finding the particles at different locations. Probability of finding particles at different locations. So classical mechanics is macroscopic, quantum mechanics is microscopic, classical mechanics is based upon Newton. So now we have got around 4 points. So now let's move on to Heisenberg's uncertainty principle. Let me move it aside and give the heading Heisenberg's uncertainty principle. Here what I can write, del x del p is greater than equal to h by 4 pi, which is equal to h by 2. So what I did, Heisenberg's uncertainty principle says that del x del p is greater than equal to h by 4 pi, which is equal to h by 2. So what is del x? Del x is uncertainty in position. Uncertainty in position. So del x is uncertainty in position, and we have to remember that Heisenberg's uncertainty principle is del x del p is greater than equal to h by 4 pi, which is equal to h by 2. Let's move on to the, no, tell one important point. Smaller is the del x, smaller is the del x, larger is the del p. Got the point? Smaller is the del x, larger is the del p. Means what does it mean? The more you know about the position of any particle, the less you must have known about its momentum. Understood? So smaller is the del x, larger is the del p. So after Heisenberg's uncertainty principle, we have Schrodinger's time-independent wave equation. So let us start the derivation of Schrodinger's time-independent wave equation. Black color. Let's see what it came. Sorry, you have to write with this. Okay. As I'm new to this, so it will take me some time. This size is okay. Schrodinger. Schrodinger. Shit. Schrodinger time independent wave equation. So Schrodinger time independent wave equation. So let's start. So we can start writing with let us consider simple wave motion, let us consider simple wave motion like the vibration of a stretched string. So what I wrote, let us consider a simple wave motion just like the vibration of a stretched string. Then let phi be the amplitude of vibration at any point. Amplitude of vibration at any point whose coordinate is x, and time is t. So we considered phi as the amplitude of vibration at any point whose coordinate is x, time is t. Let's start with our main funda. Dou square phi divided by dou x square equal to 1 by c square. 1 by c square dou square phi divided by dou t square. C, no? C is velocity of propagation. Velocity of propagation. So then this can be again written as phi is equal to f of x into g of t. So what is f of x and what is g of t? F of x is basically function of coordinate x g of t is function of time t, and g of t equal to a sine 2 pi nu t. So this is g of t, and this can be replaced by phi is equal to f of x. Oh shit, sorry. F of x into a sine 2 pi nu t. What, my eraser is not working out. So this can be written in place of this as g of t value is a sine 2 pi nu t. The phi is equal to f of x into a sine 2 pi nu t. Then if I want to differentiate this one, with respect to t, can I do that? Let's do some differentiation. If I differentiate this, dou phi by dou t, then it will be dy dt f of x into a sine 2 pi nu t, which will be f of x into 2 pi nu into a cos 2 pi nu t. Got it? So this is not enough. We have to double differentiate this as well. So let's double differentiate, and if you haven't taken a screenshot, then please take a screenshot of this. Taken? Let's move ahead. Okay, so we have to double differentiate these with respect to t. Dou square phi divided by dou t square. Let me write the product directly. Negative sine f of x into 4 pi square nu square into again a sine 2 pi nu t. Got? Or we can write this in another manner, minus f of x, sorry, it is in the pen is showing some problem, into 4 pi square nu square into g of t. I don't know why the pen is not doing like this. Let me do it again. Write this properly once again. So this can be written as minus f of x into 4 pi nu square into g of t. Perfect. So now what to do with all this? Simple. Let me move ahead. So previously we had seen that phi equal to f of x into g of t. This we had seen it previously. Now we have to differentiate this one with respect to x. Got it? We have to double differentiate actually. Let's start with it. I will directly write the values. So dou phi by dou x equal to dou x f of x to g of t. Then again on double differentiating, dou square phi by dou x square, this is dou actually, is equal to dou square fx into g of t divided by, sorry, this is divided by dou x square. Now big thing. Now we have dou square phi by dou x square, and on the above step we also have dou square phi by dou t square. And so we can put it over here. We can put the value of dou square phi by dou x square and dou square phi by dou t square in this first equation and get the value. So now we have to substitute these two values. Let's get started. Okay, now start writing. If we do all the substitution, then final answer would come dou square fx divided by dou x square equal to minus 4 pi square nu square divided by c square fx. And c by nu is lambda, so nu by c is 1 by lambda, so this can be written as minus of 4 pi square by lambda square into f of x. Done. So this is basically the thing. Now what we saw till here, it was only one dimension, but we need to extend this up to 3 dimension. It is x, y, this is y, and z. So let's move ahead. Dou square psi by dou x square plus dou square psi by dou y square, dou square psi by dou z square equal to minus 4 pi square divided by, this is pi square, divided by lambda square into psi. Here this lambda, we can consider lambda as h by mv. True, this can be considered as h by mv. So the final output would be dou square psi by dou x square plus dou square psi by dou y square plus dou square psi by dou z square equal to minus 4 pi square m square v square divided by h square whole into psi, where m is nothing but mass, v is nothing but velocity. So wait. This derivation has not been completed till now. Some more things are to be added. That will be added in the next video. So till here, those who have watched the full video, I want to say something from the bottom of my heart. That is none other than a big thank you So stay updated for new videos. Do subscribe to channel, like the video, share the video. Thank you.